Hey everybody, Mr. Gibson here. For this assignment, you guys are answering the questions in the margin for the interactive notes for 4.2. And those are all going over ionic bonding and ionic compounds and all of that stuff. So in 4.1, we talked about how ions are formed. 4.2, we're talking about what happens when you bond ions together. And what we get is an ionic compound. So I've gone through, I have filled in all the blanks for you. All you guys need to do is go through and answer the questions in the margin. Use the information here. Pull out the information that you need in order to answer the questions in the margin by adding text boxes, okay? Also, something you'll want to do as we go through is anytime you see practice, you're going to want to do that. So usually what will happen is it'll have some information, an example. So for this, I'm showing you how to do the counting ions method of writing the formula for an ionic compound. I show you how to do it here with 3 examples, and then you guys do practice, okay? A little bit of practice here as well. Then I show you how to do the swap and drop or the crisscross method. I have the steps, the examples, and then you guys try it on your own with the practice. Big thing about chemistry is it's really hard to learn it just by reading or being told something. You really need to practice it in order to get good at it, okay? Then you guys are going to do the summary page. Now, once you've done the summary page, watch the rest of this video as I go over the answers on the summary page, okay? So if you haven't filled this out just yet, go ahead and pause the video, complete the activity, do the summary page, and then keep watching the video in order to make sure you got those correct. Okay, so if you're still watching now, I assume you've done the summary page, and let's go over those answers really fast. So what 2 kinds of elements are ionic compounds made from? They're always made of 2 kinds of elements, metals and nonmetals. They're made of 1 metal and 1 nonmetal, okay? Number 2, the electrostatic force between cations and anions that hold them together is called an ionic bond. That ionic bond is formed by the electric attraction of the positive ion to the negative ion. Just like 2 magnets that stick together, the same thing with these ions. We call that attraction that holds them together because 1 ion is positive, 1 ion is negative. We call that an ionic bond, okay? And there are 2 factors that tell us how strong that ionic bond could be. It could be the quantity of the charge. So if it has a bigger charge, like a +2, +3 charge, it's going to have a stronger bond, and also the distance between the ions. Number 4, ionic bonds form by the transfer of 1 or more electrons from a metal to a nonmetal. So remember that metals are going to form the cations. They want to lose those extra valence electrons. And so when they lose those, they're going to give them to a nonmetal who's trying to get extra valence electrons so they can have full shells like the noble gases. And so when that transfer happens, you have the metal losing an electron, giving it to the nonmetal, and then that bond forms between them, okay? Number 5, do atoms gain or lose stability when forming bonds? They gain stability, okay? They become like the noble gases because the metals are losing the electrons that are just extra, and now they're like the noble gases, and then the nonmetals are gaining the electrons they need from the metals so that they can be stable like the noble gases. Number 6, what is the electrical charge of an ionic compound? So here's the thing. We've talked about charges, metals having positive charges, nonmetals having negative charges, but an ionic compound, when those metals and nonmetals are joined together, that compound has a charge of 0. The positive and negative charges will cancel out. This is super important for you to know. Okay, the number of positive charges and the number of negative charges are equal. They cancel each other out. Another name for ionic compound, number 7, is salt. Now, we kind of have just been used to calling table salt salt. Sodium chloride is the formula for that. But any ionic compound is technically a salt. Okay, so that's just another term, another general name for ionic compounds. We can call them salts. Okay. What are the three major properties of ionic compounds? Well, one is that they're crystals at room temperature. If you were to look at these guys under a microscope, you would see a crystal, and usually they're really pretty. Another major property is that they have really high melting and boiling points. So the ionic bond that holds these together is really strong. It's really hard to break it up. So in order to melt them, or especially to boil them, you have to get them to really, really high temperatures. If you don't believe me, take salt. You can put it on a frying pan and crank that thing all the way up. You are not going to melt that salt, okay? Because it's an ionic compound. It's got a really high melting point. And another really important thing is that they conduct electricity either when melted, which is hard to do, or when dissolved in water. We actually call these electrolytes when they're dissolved in water. You may have seen that in like Gatorade and stuff like that. So when you look at a Gatorade bottle and you see like it has sodium and potassium, it's talking about those ions, these ionic compounds being dissolved in that water. And they conduct electricity. So pure water on its own actually doesn't conduct electricity. If you did the hook activity or the APK where I did the demonstration, you saw that where pure water doesn't conduct any electricity. Only when ionic compounds are dissolved in water will it conduct electricity. Number 9, the number of ions of opposite charge that surround an ion in a crystal is called a coordination number. Okay. Number 10, the smallest representative unit of an ionic compound is called the formula unit. So an ionic compound is never on its own. You never just have one sodium and one chloride. Okay, it's in a crystal with a whole bunch of them. And the formula unit is just the ratio of how many of one atom you have compared to the other. Number 11, true or false? We always write the number 1 in the chemical formula. That is false. Usually, if there is only one of a certain atom in the chemical formula, we just leave the one off. So like sodium chloride is NaCl. There's one of each, but we don't write Na1Cl1. We just know if there's not a number, there's only one of those ions, one of those atoms, okay? Number 12, what are the two methods we use to predict the chemical formulas for ionic compounds? I accidentally left that blank. That is the counting ions method and the swap and drop or the crisscross method. Those are interchangeable. You can call it either one. So in the counting ions method, you literally, if I gave you two atoms, you would figure out their charges and then count up how many you would need in order for those charges to cancel out, okay? And in the swap and drop or the crisscross method, you find the atoms, you write the charges, and you just crisscross them. You swap them and then drop them down and then throw the charges away. And that would give you the correct chemical formula. So here is showing you the counting ions method. So calcium and it says predict the chemical formula for the compound formed between the following pairs of elements. We've got calcium and phosphorus. So calcium has a +2 charge. Phosphorus or phosphide has a -3 charge because it's in group 5A. Okay. Now to figure out what their formula would be, we have to, using the counting ions method, you have to figure out how many of each atom do you need for those charges to cancel out. Well, if you have 3 calcium ions, that overall charge, because each one has a +2 charge, would give you +6. Now, if phosphide is -3 and it needs to cancel out a +6, then how many -3s do you need? You need 2 of them because -3 plus -3 is -6. So +6 plus -6 gives you 0. How many of each atom did we need to cancel that out? We needed 3 calcium, so it's Ca3 with a little subscript there, and P2 because we needed 2 of those. Okay, those subscripts tell you how many of each atom that you have. So Ca3, P2. Here, let's do it with strontium and iodine. So strontium has a +2 charge. Iodine has a -1 charge. Notice we don't write the 1. We can just put the minus. So if strontium has a +2 charge, we need an overall -2 charge to cancel that out. Or if iodine only has a -1 charge, we need 2 of them to give us a -2 charge. So it's Sri2. Okay, here is aluminum and phosphide. Aluminum has a +3 charge, phosphide has a -3 charge. Okay, so we only need 1 of each of those because +3 plus a -3 would give us 0. It's already canceled out. And remember, the compound has to have a 0 overall charge. So we just need one of each. So it's just ALP. We don't write AL1P1, we just put ALP. Now, if you use the crisscross method here, you may get a little tripped up because you would have crisscrossed 3 down to here, then this 3 down to here, and gotten AL3P3. But we can't leave it like that. Remember, a formula unit is the lowest whole number ratio. So we could divide both of those numbers by 3 and get 1. You got to simplify it down, just like in math or something like that, okay? So I hope this makes sense. I hope this helps. If you guys have any questions at all about anything we've covered, please feel free to email me, okay? Good luck, guys.